Thanks a lot for having me here. And so I'm Ruggero Tacchi from Quid, and 3 of my coworkers are also here. So if you have questions later, there is a bunch of people that can probably answer. So let's start just giving like a pretty quick introduction about what Quid does and how we use big data and big data visualization at Quid. So at the moment, for some reason, you can't see the first rectangle, but we deal with it's the beauty of
visualization.
Yeah, exactly. PowerPoint. But so at the moment, our main data sets are private company data, which is the missing box, news data, patent data, organizational data, and scientific papers. So what do we do with this? We try to extract insights out of text and try to help other companies to answer their strategic questions. So let's start giving an example. If you were asked who owns the discussion about the future of the car, this would be a pretty tough question to answer. Do you guys have any guesses? Tesla is one. No one else? GM. Google. So first thing you can try is Google. And I'm not going to type who owns the discussion about the future of the car in Google, but I can try to type future of the car. And as you can see, I'm sorry if I'm pointing at this board as opposed to the other one, but you can definitely see big numbers here. And the problem of that 1.8 million and 1 billion on the other side is that you're actually only looking at 5 to 10 articles. And they're not really talking about really the future of the car. They're talking about some individual aspect. So you don't really understand anything about the future of the car just by Googling that. And so even though you may think about going to the second page, our friend from XKCD tells us that it's scary to go to the Google second and third page, and you're never going to understand anything anyways, except for some rare cases. So the point is that search is hard for these kind of questions. You can't just rely on a search engine to give you any insights. So one thing that we can do is that we can take all those articles, that million articles potentially, select the ones that we think are more relevant, and try to aggregate information about those. So first thing we find is something like this. So Google is effectively owning the conversation about the future of the car. And not only that, but we can go a little deeper and see that it's not so much about new car features, which is, for example, what other companies are important for, but it's about the autonomous driving. And with tools like this now, you can take all those articles that were meaningless before it was just a number and actually try to aggregate the information and to get some insights. And so if you think about any of these possible companies and they want to understand who's their most dangerous competitor in the next few years, it might be not necessarily so sure that it could be another car company. Maybe it's Google. Other questions that we can try to answer is like, who's important for NASA when it comes to press releases? And so we apply some similar technologies, and we can try to measure how much specific news sources are aligning with how NASA presents itself through their press releases. So there will be a lot of news sources that are very well aligned, like New York Times, for example, and other ones that are really bad that I didn't specify just so that no one gets offended. I don't know if one of you works for one of those, so it's better not to say anything. But anyhow, so with this, there is already some aggregation level, okay? So we're taking a lot of data, and at least we're giving you some numbers that you could potentially can use. You can use in business decision, you can use in strategic decision, you can pass higher floors, and like they are happier with real numbers than with just a guess, right? Or at least we wish. But The problem is that these are still just lists. And so I'm going to get help again from XKCD. And the point is like, yeah, you go to the movies. You have to decide how to sit with your friends. And there could be, I don't know, in this case, some person is in love with another person, but they're not sitting next to each other. And so what is the problem behind this? It's just that in reality, friendship between people is a social network. So the structure is a lot more complex. So you can't just approach big data with just a list of aggregated numbers. You also have to understand the structure and the interplay between all the parts. So what we need is networks. It's not just lists. So one example, starting from the NASA conversation, could be, let's have a look at all these articles that we aggregated, and let's have a look at how they relate to each other. So we put it in a network view. And first thing that we can do is try to understand how they are grouping together. So this is one possible layer that we apply to the data, and is about, let's have a look at the temporal discussion. Are they talking about the past, the present, or the future? And so we can notice that there is some interesting maybe overlap between the past and the future. There is a lot of conversation about the present. And we try to, piece after piece, we get closer to what we're really trying to ask. And then we can go even deeper and see, like, oh, let's have a look at these individual clusters. What are they talking about? And so we see that the current conversation is about the moon, the Hubble telescope, Mars Curiosity. And then the future that was up there is about SpaceX, since it's a very promising company, but they still don't actually do anything in space. They're just testing. And then they're talking about the past, and probably the space shuttle, like after the shutdown, is a main topic. So this means that now I have an understanding of the conversation that goes around NASA and around the topics that NASA cares about, which was impossible to know just with lists, because the main problem I would have at the time would be, how do I know if I'm actually covering all the aspects? And how do I know which ones are relevant or which ones relate to each other? So when I have maps like this, I can finally try to understand the relationships between these topics. And so let's step back a little bit, and let's give a quick review of how we get this from the original data. So basically what we do, and I'll go into detail, this is just an introduction. What we do, we take documents that you can see on the left side. We extract entities and text and keywords from these documents. We use techniques to identify how similar documents are based on their language. And then we use these similarities to form links between between articles or any sort of document. And then we use all these links to create our network. And then we go into the visualization. So to give a little more detail, you can think of this. We have several data sets. Some data sets are more structured than others, but we care a lot about the unstructured data, because that's the really painful point for a lot of people. So that's what we're trying to solve, right? And so what we do, we take the whole text, and we start trying to understand which concepts are important in the piece of text. And then when we have a lot of these concepts, we can sort of have an idea of their representation in this text space, like a vector space of keywords. And so we can assign some sort of profile to a document, which in this case, you can think of it in several ways. One way that is easy sometimes to understand is that you can think of this as individual topics. And so you have a high score if your document scores high in that topic rather than another topic. A lot of these things are dynamical, so they're not prefixed categories, but it's a good way to represent it in your mind. So once we have this for one, we can do it for all the documents we have. And so we can start to compare each document with each other document. And then there is several mathematical ways to do this. Everyone has their own. But basically, we can spit out a number that tells us, according to our algorithms, how similar two documents are. Once we do this, then we decide that, for example, in this case, that the red and the blue are connected. They share a lot in common. And so in our maps, we form a link. And then, so what do we do with these links? That's just the first step. Now we have our network. So what we do is this. Well, first of all, we can't just plot a bunch of dots with a bunch of links because it's not helpful to anyone. So we apply a force-directed layout that basically helps us identify clusters and visually guides us towards understanding the relation between big parts of the network. Then we study all the interactions between all these nodes, and we look at all the links and how clusters form. And so we apply our clustering algorithm that you can see in this matrix, which is a matrix of weights of the links between all the nodes. And so thanks to our clustering, we can see now they're all sorted. And we can identify, in this case, I don't know, it's probably about 20 or something like that, areas in which there is more connections. So these will form our clusters. And then we can now superimpose these colors or these clusters on top of our networks. And so that's what you see here at the bottom right. So now we have a view of a network with each individual cluster, and we can start to study each individual cluster separately and then start seeing if two of them are about the same thing or if they're different, what's the relation between them. Once we do some of these analysis, maybe we think about looking for different metrics. Maybe if this was news articles, I want to know how much they're shared socially, or I want to know something else, like, I don't know, like how many times other journals publish the same or similar story or something like this in terms of the clusters. So how many people care in general, and so I apply my additional metric here. And then after that, now that I have a filter view, I can go back to a list again. So I start with a list that is not usable, and I make it into a network, and I use the understanding of the network and the relation between the parts to, at the end, go back to a list, but this time is a list that depends on what I'm looking for and in which I can actually try to get some insights from. It's not anymore just a random list based on just some initial score. It's now driven by the actual insights that you're trying to get out of this. And maybe the best thing that I can do is a little demo. So let me see. I think I need to resize. Okay, so this is our platform, and it's a web product, so you can just use it on your browser. Like, as long as you have a subscription, you can browse it and you can do everything on your computer. So what we're looking at here is a company network. So the first example we had was news articles. This is instead private companies. So each node in this graph is a company. And the similarity between two companies is what's driving the links. So if a company describes itself and its product in a certain way, and another company is describing itself and its product in a similar way, two companies get linked. So if I click on one of these companies, I can look at the neighbors, and I can see which companies are similar. So let's step back for a second, and let's see. So first thing that I can do is to look at a company, and immediately I can access the information from the database. As you can see here, there is a founding year, there is investment received in a certain time. This was Q2 of 2013. So all the companies in this network are companies that received one investment, at least that they disclosed the existence of one investment event in the second quarter of 2013. So this is particularly useful if you want to invest, for example, in a company, or if you want to acquire a company, it's useful for you to understand who is receiving attention from other investors to understand how the space is growing. So the high-level buckets that you can see here, sorry, the screen is smaller, so it's harder. In a normal, yeah. So the high-level buckets that we detected with our algorithms and then renamed based on our understanding are commerce and finance, social apps, basically enterprise, probably software in general, but any enterprise product, and then IT, infrastructure, engineering, and health tech. So what's interesting about this is also understanding now the structure and the relationships. You can see how health tech is a little separate from everything else. The closest thing that they have is engineering, probably because there is some heavy influence from engineering towards health tech. And then you can see how commerce and social are overlapping each other, and marketing as well here in the blue, in the darker blue. One point that we hear pretty often is that no one understands commerce and finance because they all seem to do the same thing. And in a way, this is initially at least reflected here as well. Like the space is much tighter. So the spatial representation can actually have a business implication, which is it's much tougher to understand what companies do in e-commerce and how they differentiate from each other, which probably the answer is that they don't really. There is a lot of companies that do the same thing. So it's harder even to make it in that space. So if you're an investor, one thing that you can think of is, well, maybe I don't know if I want to invest there because there is already a lot of players. Maybe I want to invest in areas that are a little more sparse, in which there isn't too many people doing the same thing. Or, I mean, you can have your own evaluation about this. So things that you can search for example, is like, 500. 500 startups as a list of the investors. So this search will give you basically the footprint of what 500 startups is doing. They're investing in all these companies. And you can look at other ones. In-Qtel. And you can see that In-Qtel is more active in engineering rather than anything else. Very different footprint. And then you can look at the founder fund, which is where Peter Thiel is. And this is also kind of proving his hypothesis, when in a way it's not proving it, in a way he's showing it. Like they want to invest in ideas, they don't necessarily care about which field. So what you see here is that they're actually covering everything as long as they're interested in it and they think it's a good idea. They don't really care about if it's healthcare or if it's commerce. So you can start from here, and of course you can do various things. You can take all these companies, you can tag them, you can access them later. But then what you can do is you also say, okay, maybe I trust them. I'm a different VC, but I sort of trust what they're doing. And so I want to see the neighbors. So I want to see all the companies that are doing something similar to them. So I can expand my selection. And now I have a portfolio of possible 127 companies that I may want to look to find my investment targets. So if you think about this, what happened here is that instead of having a huge database on which I'm writing a very complex query that like takes care of who's investing, when they're investing, who's the top investor, what kind of big bucket of technologies it is, I am sort of like doing that first step in a network. And all I have here, it now becomes contextual. And so I can do a lot of interactive contextual searches in this network, which is a lot more powerful than just having a very good query on a very large data set. So this way is kind of bringing big data into, through the visualization, something that you can easily use for your own decisions and for strategy. And especially in a field like strategy, in which probably the most complicated tools so far were Excel and PowerPoint, like having the ability to almost query yourself a very large database without like needing like complex queries or people who understand how to query, like is very powerful. And to the point that I can show also a couple of things that you can do by filtering dynamically. So now that we have a network, for example, you can have network metrics, which is something that makes sense also in a context. You don't want to do that for your entire database. You don't want to have 1 million documents or 1 billion documents, like and all analyzed together like in a graph a la Google, because that loses the context. That's just a score basically at the end. So what you want to do is that now that you made your subset manageable, now you can try to understand the structure also using the network structure. So for example, here I can select one network metric between a centrality that some of you may be familiar with, others may not, but basically what's the business interpretation of between a centrality is a company that is very important for the structure of the network, but not at the same time, not necessarily central in a cluster. So it's helping you find companies that are bridging different technologies that may be innovative. So using this dynamic filtering, you can access additional information that would not be available at the beginning from your database. And then you can also add something else, like your own metrics. For example, here we can look at the multiple on the last round. So you can associate, based on the financial information, how much bigger is your last round compared to the previous round. So how much are you scaling? And this is an additional filter. Now you have innovative companies that had at least a factor of 4 in growth. And having the visualization and the interactivity of visualization is making this operation incredibly easy if you think about any other way to do this. Yes?
Can I ask a question?
Yeah.
Do you support natural language here?
Yes.
Like instead of just going by the filters that you provide, if I ask a question based on like a simple question like give me my top 10 customers for Q4.
Yeah,
something like that.
Not in this version here. We do support domain-specific language, though. So it's not at this level. It's at the level before that I didn't show when you're creating your portfolio, in which you can ask that question. We will eventually introduce it here as well, but I can't show it right now.
And does the visualization change based on the question that you ask, or is it always going to be one type of chart you are showing right now?
Well, again, it depends on where you are in the process. You can always go back and increase the number of nodes or companies that are in your network, and that will dynamically change. So you can always do that. Like, it's not something that I can do in 1 second, but if you were like using the product, you could probably do it in 5 minutes, something like that. So it's not very complex. Like if you were to change completely the original query, you have to go back, but yeah, you can do it.
A quick question.
Yes.
In your creating network based on similarity, do you use weights or is it 0, 1? 2 documents are either.
We use weights. Yeah.
Okay.
That I can show you. I'll go back. So in this view here, this is the weight matrix. So maybe it's harder to see, but the dots are darker if the weight is stronger. So smaller weight has a lighter. And so that has an implication in the clustering detection and the network structure in general. Yeah, so this is a good point, timing-wise as well, to finish. And so yeah, I just wanted to remark again that in our opinion, the strong point that we have here is that we want to make big data accessible for business intelligence. And a way to do this is through these dynamic and interactive visualizations, because you can leverage your enormous database and your enormous architecture that you have in the backend, but you can expose it to any user, and it's very easy to access information. And the other aspect of it is that normally, even from these big queries, it's very hard to understand the mutual relationship between the parts. But when you have a network view, like in this case, you can actually try to understand how two different technologies in this case, but you can have many more examples, how they connect with each other. And so what's the connecting technology? What are these companies that are kind of like in the middle of two different technology? What are they doing? How are they using both technologies? And so that can be very informative. And if you think about the idea that this approach can be used with any document set, then it becomes very powerful. So, yeah. We also have 3 other people from Quid. Danielle is the backend guru person and also data scientist. Kartik is an associate and expert in all the software stuff and insights and business intelligence in general. And Joy is the data visualization guru at Quid.
Excuse me.
Oh, yeah.
So, when you do clustering, so it's the third step in the previous slide,
Yeah.
if I remember correctly, do you use a custom algorithm to make it, or a well-known algorithm?
We do a little bit of both. Some community detection algorithms are available just in the literature. And then we do our own modifications that, of course, I can't share. But, yeah.
Hello.
It would be better to have the question in the video. Sorry about that.
Hi.
Hi.
So what's the size of the data sets we're talking about here? I mean,
That,
the
yeah.
performance and scalability of the solution. I mean, what's
So-
the biggest document size you have tried to cluster and visualize?
So I guess that question is, it really depends. Like each data set is completely different. Like the side of a company, private company data is large, but it's not as large because we just don't have 1 billion companies. Otherwise, every person pretty much would have a company. But for other data sets, if you think about news, then there is definitely like millions and millions of articles. So it's certainly in the terabytes, and then it depends on the specific data set.
And what does the platform expect? Do you expect that the users of the platform are just uploading documents or links? Or
No, so in
what
our core products at the moment, like we have a lot of internal products that we work with on an engagement basis, so depending on our client requests. And then we also have 2 data sets that are completely available to the customers as long as they have a subscription. And those are private company data and news data. So those you don't need to do anything. You just log in and you have access basically to our database. You can query, you can get the networks, you can explore them, you can get your outputs, you can export to Excel if you love Excel, and things like that. Like for other kind of data sets, we at the moment do it on a based by like contract by contract, depending on the interest. And the direction is adding more data sets. For example, we are using at the moment also patents and scientific papers extensively. They're still not available in the platform, but they will be shortly enough.
Thank you.
Hi.
Hi.
So, looking at the example that you gave, where you were looking the documents as a data set, so all the data set that you use are kind of documents only, or is there any other kind of data set that you can use? Because my question comes from the idea that if you're looking at documents, and the way I understand is you're looking for specific words or keywords into that. Now there is a lot of contextual information also present in documents. Are your algorithms able to get that kind of contextual information? Because, for example, I can give you a very good example that I'm comparing two products. Like there's a product 1 and there's a product 2. I'm saying product 1 is good and product 2 is bad. But when you look it up as in terms of how many times that product B is coming up in your documents, it's going to raise your number. So there's a lot of contextual information which is also present in those kind of documents. So how is your algorithm able to take care of that, one, and what is the kind of accuracy that you're expecting out of this kind of contextual information that you're extracting from the data?
Yeah, so there is some level of contextual information that we can extract. There is certainly like issues with like trying to like get one algorithm to work for everything. So sometimes you adapt it for the specific purpose you need. But overall, it's pretty much the same. And I would think that the accuracy in this case is like, so let's reframe it like, what are you trying to map here? You're trying to map similar technologies, right? So what you think as accuracy is that if I have a cluster of companies that are actually doing the same thing or not. So accuracy in that sense is usually pretty high. It's like above 90%. Like of course, if you're trying to identify the specific circuit that a hardware company is using and try to see that, that might be too much that you're asking for. But the purpose of the company data set is not finding that sort of insight. For that, you would look, for example, more for patents. And so it's easier to distinguish between specific circuits, for example, or like molecules if you're looking at chemistry. But for our corporate clients, for example, what they really need to know is how much money is going into a field. So for them, that's the main information. So once you start already with a level that is above 90%, and then you can make sure that everything relevant is correctly placed. But that's usually the case. It's very rare that a company is completely misplaced.
One last question.
For the lengths of the arcs in the network,
yeah.
Are they only based on similarity, dissimilarity, or does decluttering the presentation come into it?
Yeah, I'll give you a quick demo just so that you can understand this in an easier way. So I'm filtering out now a couple of topics, and I'm only leaving commerce and finance, enterprise, and IT infrastructure. So in the current position depends on the previous view, in which the distance is usually proportional to the similarity, but not necessarily of only two objects, because when there is clusters, then two clusters are pulling apart or they are actually pushed together, depending on what the interaction is. So basically, you can think of it as this is a force layout algorithm. So basically, you can think of each link as a spring force, and each node is pushed away from everything else. And the good thing is that if you want to study the local properties, you can apply the layout again, and things rearrange according to the objects that are in this view at the moment. And so you can look at subsets and try to understand the structure in a smaller view.
Thank you so much.
Okay, thank you.